Hello everybody. This is lesson 22 of the lecture Macroeconomics. I will discuss slides 141 to 164 of Chapter 4, the Keynesian model. In this lesson we will analyze the consequences of monetary policy under the special assumptions of the Keynesian theory. In the preceding lesson, we analyzed fiscal policy under the assumptions of the Keynesian theory, where we neglected the existence of money supply and money demand. We implicitly assumed that we are dealing with a pure barter economy, an economy that works without money, where goods and services are exchanged against goods and services. That's what we call a barter economy. Now, under the existence of money usage, which means money supply, money demand, the effect of fiscal policy is somewhat dampened, somewhat reduced, because any increase in GDP increases transaction money demand, and consequently the interest rate goes up somewhat. And the higher interest rate in turn reduces investment goods demand, such that total demand goes back a little bit, and as a result the increase in GDP is correspondingly smaller. Nevertheless, even if we take care for the usage of money, the net effect of fiscal policy on GDP under the special assumptions of the Keynesian theory is always significantly positive. So if we have expansionary fiscal policy, GDP will always grow, even if we take care for the usage of money. In this sense, neglecting money was harmless. It was a useful simplification to focus on the specific way fiscal policy works under the assumptions of the Keynesian theory. Now, of course, where we want to analyze monetary policy, we cannot neglect the existence of money. Therefore, we have to introduce money supply and money demand. Let me start with money supply. What factors determine money supply under the assumptions of the Keynesian theory? Well, it's quite simple. Just as under the assumptions of the neoclassical model, the central bank determines money supply. How much money in nominal terms is introduced into the economy. For example, the European Central Bank would set a money supply equal to 5 billion euro. So money supply, for which we will use the shortcut MS, is expressed with the dimension currency units like euro or dollar and so on. It's nominal money supply, that's important. As the discussion of monetary policy in chapter 6 by the end of this lecture will show, most central banks offer their money in various ways and channels as a credit on the capital market. So money supply enters modern economies typically in terms of credits. Therefore, we can simply add money supply of the central bank to the credit supply of households, which we also call household savings. So under these assumptions, total credit supply now will equal money supply of the central bank plus credit supply, the savings of households. Consequently, total real credit supply equals the sum of the real savings of households plus the real value of money supply by the central bank. Now we've already observed that central banks offer money not in real terms but in nominal terms, currency units. For example, the European Central Bank offers currently approximately 5 billion euro in nominal terms to the economy. However, we have so far expressed the credit supply of households in real terms, which means we have measured savings of households in units GDP. Therefore, we can now not simply add nominal money supply plus the real savings of households. We can only add things that have the same dimension. Therefore, we have to recalculate the nominal value of money supply into the real value of money supply. This might sound a little bit complicated, but in fact it's quite simple. What we have to do is we have to divide nominal money supply by the price level, just like this. The price level tells us how much money we have to spend to buy 1 unit GDP. That is the typical dimension of a price. A price has the dimension currency units that have to be spent to buy a certain quantity of a good. Here we have only one good, we have only GDP. Currency units in this case would be euros, so the price level is expressed in euros per unit GDP. The number of euros we have to give away to buy 1 unit GDP. And if we now take the nominal supply of money by the central bank and divide it over the price level, we receive the numbers of GDP units we can buy for the nominal money supply of the central bank. That means we have calculated the real value of the money supply. So the real value of the money supply is the nominal value divided over the price level. This has the same dimension as savings supply by households, and therefore we can now add both components up and we receive the total credit supply. Let's now have a look how this expression can be illustrated in the standard capital market diagram of the Keynesian model. We have already derived this diagram and used it when we analyzed fiscal policy. So we have here the supply of savings, the credit supply of households, which we call savings. It's a vertical line since we made the simplifying assumption that household savings do not depend on the interest rate, so they do not grow if the interest rate gets higher. They only depend on GDP, so we have to shift household savings if GDP changes. If GDP grows, we have to shift the whole curve to the right, and if GDP shrinks, we have to shift the whole curve to the left. The other component, the demand side on the capital market, is the investment credit demand curve of private companies. This curve has a negative slope, which means the lower the interest rate, the more investment credit is demanded by private companies in order to buy more investment goods on the market for goods. This curve depends also on the expected investment return. The investment return is a shift parameter of this curve. The higher the expected investment return, the more this curve lies to the right, and the lower the expected investment return, the more this curve lies to the left. Since a higher investment return allows the payment of higher credit interest rates, there is a positive effect of the expected investment return on the position of this investment curve. Okay, that's what we've already discussed, and now we have to add money supply. Let's assume for simplicity that the real value of money supply corresponds to the length of one little quad. Since we are assuming that the central bank will offer this amount regardless of the interest rate, the entire credit supply curve will shift to the right by the length of one little quad. This is the real value of money supply by the central bank, and since it is supplied without taking care of the level of the interest rate, so it's always the same no matter what interest rate, we have simply a shift of the savings curve of private household savings to the right by the length of one little quad. The total credit supply curve consists now of two components. The savings supply by households, the credits supplied by households, which we call savings, plus the real value of the money supply of the central bank. Okay, now we have introduced money supply. Next step is that we have to introduce money demand. What factors determine money demand under the assumptions of the Keynesian theory? Well, it's again quite similar to the neoclassical theory. Just like in the neoclassical model, firms demand money to pay their production factors, labor and capital. So they have to pay wages and they have to pay interest. For this they need money. That's our assumption now. It's not paid in terms of goods or services, but in terms of money. So private companies have to procure themselves with money. As a result, the real money demand of private companies depends now on the sum of all the real wages paid plus the sum of all the interest, the real interest payments. And we know that under the assumptions of the model here, these payments add up to real GDP, for which we use the shortcut Y. So real GDP determines basically the strength of money demand. We call this impact of GDP on money demand transaction demand for money. Because if GDP grows, more transactions have to be undertaken in the economy. A larger amount of transactions has to be turned over, and for this larger amount of transactions, people need more money. If GDP shrinks in a recession, less transactions have to be undertaken, and as a result, less money is demanded. So the impact of GDP on money demand is positive. In the original model of Keynes, he accounted also for the fact that households and firms typically care for the opportunity costs of holding money. The opportunity costs of holding money are equal to the interest rate. Because if you keep money in your money pocket, you do not receive an interest payment. If instead you invest this money somewhere, you would receive an interest payment. Because if you keep money in your money pocket, you will not receive an interest payment for this money. If instead you would invest this money in a financial asset or on a bank account, you would receive an interest payment. So keeping money means you have to renounce interest payments. For simplicity, however, we will neglect the dependency of money demand on the interest rate in the following analysis. It has no significant effects on the results and simplifies largely the graphical exposition. So as a simplifying assumption, we will not take care of the impact of the interest rate on money demand, even though it is quite plausible that it has an impact. Empirically, however, this impact is relatively small, so we make no big mistake if we neglect it. Okay, based on these considerations, how do we write the money demand? And real money demand depends on GDP in a positive way, as we have already discussed. This is what we call transaction money demand. Now, we can add now this real money demand to the real investment credit demand, and then we receive total real credit demand, which consists of two components: investment credit demand plus money demand. Now we have to illustrate this second component in the credit market. This is our first component, investment credit demand. And to this component we have now just to add the money demand additionally. I make the assumption that money demand equals the length of one little quad 2. So total credit demand equals now the old investment credit demand curve plus this amount of money, which is equal to the length of one little quad. So it's a kind of parallel shift of the initial curve with which we started the investment credit curve. That's it. Now we have here a total credit demand curve with two components: investment credit demand, real investment credit demand plus real money credit demand. Since we've made the assumption that money supply and money demand equals here both the length of one little quad, the interest rate that results in this intersection point of both curves is identical to the interest rate we had initially without money demand and money supply. So the equilibrium interest rate does not change if real money demand is exactly equal to real money supply. Under the assumptions of the neoclassical model, we've had the same phenomenon, and we called therefore this interest rate the natural interest rate, which means the interest rate that would also result in a mere barter economy where no money is used. We know already from the neoclassical theory that this natural interest rate is neutral in the sense that it does not give rise to more or less demand for goods. It will play the same role here, as we will see. Okay, now we have introduced money demand and money supply on the capital market, and we can start with our analysis. This is the demand side module of the Keynesian theory, which we have already used to analyze fiscal policy in the last lesson, with the only difference that we have now introduced money supply and money demand. With this version of the Keynesian model, we are now able to analyze how monetary policy works under the assumptions of the Keynesian theory. Starting point is here a situation where we have a demand side recession, which means GDP has fallen to a level YD1, which is smaller than the full employment level of GDP. The full employment level GDP would be YD2. This means this is a situation where we are in a recession with Keynesian unemployment. To have full employment, we would need a GDP equal to YD2. But we have only a GDP of YD1, so there is a gap, which means we are in a situation where the economy suffers from unemployment. Question is now, can the central bank do anything against such a recession? Under neoclassical assumptions, we have already seen that central banks cannot do much to change the real situation in the economy. It can only cause inflation or deflation. Question is, will this now be different? Let's have a look. Let's try what happens simply if the central bank increases money supply. The initial situation, money supply at the length of one little quad. Now let's assume that the central bank additionally increases money supply by the length of one little quad, which corresponds here to the length of 5 units. So we would then have a total credit supply not equal to 15 but equal to 20. This is now the new money supply, the old one plus 5 units. What consequences does this have primarily on the capital market? Well, of course, the new intersection point with the total credit demand curve is on a lower interest rate level, so primarily the interest rate falls to a lower level. This lower interest rate causes then an increase of investment demand. This is our investment demand curve. Given the old interest rate, we had an investment demand of 10 units. Now we have a lower interest rate, and this lower interest rate implies then a higher investment demand of 15 units. So that is the first primary effect of this increase of money supply. Lower interest rate and hence more investment credit demand by private companies. What consequences will this now have for the market for goods? Well, in the initial situation, investment goods demand was equal to 10 units, the length of 2 little quads, 1, 2, so this was the total demand curve in the initial situation. Now firms demand 5 units more investment credits, which means they will also increase their demand for goods by the length of one little quad, 5 units. So this curve will therefore also shift upward by the length of one little quad. As a result, we have now an investment demand which is equal to 15 and no longer equal to 10 units only. So this change in monetary policy has a direct impact on the market for goods. We have a higher demand for goods. We know already that the new equilibrium is given by the new intersection point with the 45-degree line. We have discussed why this is the case. And that means that total GDP grows now from 20 to a level of 30, which is exactly what we need to have full employment. So, as it seems at first sight, we have now reached a situation where the increase of money supply by the central bank has helped to overcome unemployment, which is exactly what the central bank wanted to do. Interesting aspect here is again that we have an initial increase of demand for goods by 5 units, but total GDP grows by 10 units from 20 to 30. We know already that behind this additional increase of total demand is the famous Keynesian consumption multiplier. Since we have here assumed a consumption ratio of 50%, so the consumption multiplier is 2, so the initial increase of demand is doubled by the additional increase of consumption demand. So we see again the Keynesian consumption multiplier is always working in this model. But now we have not yet reached the end of the adjustment process, because we have to take care for the fact that income of households has grown from 20 to 30. And that means now that we have no longer the savings supply equal to the old income level, Y1. We must adjust savings supply for this higher income level. Since we have consumption ratio of 50%, we have also savings ratio of 50%, and that means that from these additional 10 units income, 50%, 5 units in other words, are additionally saved. So this means that this total credit supply curve shifts now to the right additionally by the length of one little quad, 5 units. Now, taken for itself, this would mean that the interest rate falls once again to a lower level, and that would again boost investment demand, and that would again lead to an even higher GDP level, and so on. But don't worry, the economy will not explode in this way, because we have also to take care that we have now a higher money demand. Money demand depends on GDP for reasons we have just discussed, and that means if we have a higher GDP as a result of monetary policy action, we will also have a higher money demand. So we have to shift this curve also to the right. To make things simple, I shift this curve also to the right by the length of one little quad. And that means that the interest rate now stays constant. The interest rate will not fall again. And we are finally in an equilibrium. We've actually now reached a new equilibrium, which is stable. It is stable on the market for goods, and it is stable on the capital market. And we have overcome unemployment, since we have already discussed that we need a GDP level of YD2 to overcome unemployment. So that's the old story. It means monetary policy works under Keynesian assumptions. The central bank can help an economy to get out of a recession. The central bank can fight even unemployment, at least Keynesian unemployment. So it's a completely different world again compared to the neoclassical theory. Here we have possibility that an economy can fall in a demand-side recession, but we also have the possibility that the central bank helps an economy out of a demand-side recession. That's a very important difference between the Keynesian and neoclassical theory. Now let's sum up this adjustment process verbally. Initially, we had an increase in money supply by the central bank of 5 GDP units, the length of one little quad, and this causes the real credit supply to increase by the same amount, since money is offered as a credit. The result of this is a lower interest rate. Lower interest rate means that investment credit demand grows. It grows until the whole additional credit supply is absorbed, so it grows also by 5 units by the length of one little quad, as we've seen. This causes an increase in the demand for goods, so consumption demand plus investment demand grows by 5, since investment demand grows by 5 units. Now the multiplier process finally yields an additional increase by 5 units, since higher income means more consumption demand, such that finally total demand grows under the assumptions of our model here by 10 units, and GDP lies 10 units higher as in the initial situation. For the production of a higher GDP, more labor input is needed, such that labor demand grows and Keynesian unemployment disappears. In the above graphical example, the increase in money supply is chosen so that the resulting GDP level is large enough to cause an increase in labor demand that completely eliminates Keynesian unemployment. Of course, this is not necessarily the case. If the increase in money supply by the central bank is not large enough, unemployment will not disappear completely. In this case, the central bank would have to increase money supply additionally a little bit in order to approach more and more full employment. So in reality, where the central bank does not have all the information about the economy that we have here, given our graphical exposition of the economy, the central bank can use a kind of piecemeal approach to get closer to the target of full employment. If the increase of money supply by the central bank would be too large, then unemployment would rise above its long-run equilibrium level, so we would have overemployment and an overheating of the economy might result. If the central bank wants to avoid this, then the central bank has to be careful with its increase of money supply. It has to use a kind of piecemeal, step-by-step procedure. Besides the increase in labor demand, GDP growth has two further effects. First is that household savings grow by the increase in GDP times the savings ratio. In our diagram, total increase of GDP was 10, savings ratio is 50%, so savings grow by 5 units. Additionally, money demand grows since the transaction of a higher GDP needs more money. We've made the simplifying assumption that the increase in savings exactly meets the higher demand for money. Of course, this also must not necessarily be the case. It is as well possible that the increase in money demand is, let's say, too small to absorb the higher savings of households. In this case, the interest rate would further decrease. And this lower interest rate would then cause investment to grow further. This would cause GDP to grow further, and this would cause money demand to grow further until the new money demand level adds up with investment demand to the total credit supply. So even if the increase in money demand is initially not strong enough to absorb the higher savings supply, there will always take place an adjustment process such that by the end of this process, additional increase in money supply is equal to the additional increase in savings supply, and the whole adjustment process comes finally to a standstill. In case money demand would be too strong, of course, the opposite happens, and in this case too, by the end of this adjustment process, money demand would be equal to money supply. So this is, in verbal terms, the adjustment process that we have analyzed graphically. Now let's turn to the question why monetary policy is able to cause an economic recovery under Keynesian assumptions in a recession situation, but not under the assumptions of the neoclassical model. Under the assumptions of the neoclassical model, the supply of goods is fixed, depends on the capital stock and the equilibrium labor input. An increase in the demand for goods can therefore not cause an increase in the supply of goods. If the central bank increases money supply in such an economy so that households demand more goods, this causes excess demand for goods, but this excess demand is not met by a higher supply of goods, and therefore finally excess demand leads to an increase in the price level. Under Keynesian assumptions, this is completely different, as we know. In the Keynesian model, goods supply always adjusts to goods demand. That's what we've called Keynes' law. An increase in money supply, which causes an increase in demand for goods, can therefore cause an increase of total production. So in last instance, it is Keynes' law that is the reason why here monetary policy works. Since under Keynes' law, firms adjust their production always to the demand of goods in the short run, any increase in the demand for goods will cause an increase in production and therefore in labor demand. And that's the reason why the central bank can help the economy out of a recession with Keynesian unemployment, such that finally the economy reaches a new equilibrium with full employment. Okay, so much for today. The next lesson we will discuss the long run implications of the assumptions of the Keynesian model.